This is for Year 12 Specialists. It comes out of VCAANH Northern Hemisphere 2019 Exam 2 Question 1C. So we've already done 1A and 1B. We had to verify that this sits on the line of L, which we've done, and we had to verify that L is that line. Okay, so what have we got? I know that L is the line that goes through 0, 0 and has a gradient of minus root 3 because it's on the line and the line is y equals minus root 3x. And I have a circle which is here, z minus 1, and that's centered at 1. So if it is equal to another circle that's centered somewhere else, and those circles are equal, then that place must be over here. So that from there to there is a right angle, and there to there is the same distance. Because in effect, what we've got is, when the two circles have the same radius, then they touch on this line. If this was a little bit bigger, and this one's a little bit bigger, they still intersect on the line. So what I'd like to do is I'd like to find the corresponding spot over here and find out the center of it. So what have I got? I know that this line has a gradient of negative root 3, which means that's 60 degrees or pi on 3, because the angle is the tan of the gradient. Sorry, the other way around. The gradient is the tan of the angle, and the angle is the inverse tan of the gradient. So if I know that this point here is 1, and I draw this perpendicular line, then what I'm looking for is the spot over here, so that this distance and distance is the same. So if I've got a right angle triangle where the hypotenuse is 1 and this angle is 60 degrees, then that's going to be root 3 on 2, and that's going to be a half, which makes that root 3 on 2 and that 1/2 to get to that point. So I know that this is also root 3 on 2 to go from here to here. So now, if I consider this triangle, I know that that's 30 degrees, so that's 30 degrees or pi on 6. And I know that's root 3 because root 3 on 2 plus root 3 on 2 is going to give me root 3. So I could find this distance because the cos of 30 equals root 3 on 2, which means that x on root 3 equals root 3 on 2, which means x equals 3 on 2. So that distance all the way across there is 3 on 2, and if that's 1, then this is a half, so that point there is negative a half, so that point there is negative a half. And if I was to find y, the sine of 30 is equal to y on root 3, and a half equals y on root 3, y equals root 3 on 2. So this is negative root 3 on 2, so negative root 3 on 2. Therefore, the center of my second circle has these coordinates. So that must be z plus a half plus root 3 on 2i. And since it's in the form of z minus z, z1, that's what it was, z1, therefore z1 must equal negative a half minus root 3 on 2i. Now, just to confirm that that is the case, not that I would need to confirm it, but just to confirm so that you're aware that I do actually get the right answer. So I've got z minus 1 equals z plus a half plus root 3 on 2I. So it's going to be the square root of x minus 1 squared plus y squared equals the square root of x plus a half squared plus y plus root 3 on 2 squared. But x squared minus 2x plus 1 plus y squared equals x squared, 2 times the first, plus x plus a quarter plus y squared plus root 3y plus 3 on 4. A quarter and 3/4 is 1, and that will sum to 0. The y squared sums to y squared. The x squared sums to 0 with the x squared. So if I move this over, that will give me minus 3x equals root 3y. X equals negative root 3 on 3y, which is x equals, which is y equals negative 3 on root 3 x, which is y equals negative root 3x when you rationalise the denominator. Okay, so can I go back to the logic of what's going on here? I've got two circles. The two circles are equal to each other and they intersect along a particular line. So I had to find the centre of the two circles where they both make right angles to this line because they're both perpendicular. Because if I go from here to there and there to there, those are equal to each other. That's how you do 1C.